Hello friends, this video on Haloalkanes and Haloarenes part 29 is brought to you by examfear.com. No more fear from exam. Let's start with the first electrophilic substitution reaction, that is halogenation reaction. So what is halogenation reaction? So I have a haloarene now because I'm talking about the reaction of haloarene. So let's have this haloarene here. Let this be Br. And let me add a chlorine here. And to make this chlorine electrophile, what I have to do is I have to use AlCl3 or FeCl3, right? Anything I can use. So let me use AlCl3, right? And that will be anhydrous. Now what will happen is, what I'll get is, as I told, it's ortho and para writing group. So I'll get a Br here, and I'll get a chlorine here, and I'll also get a chlorine at ortho position, but this will be my major, right? This is 1,4-dichlorobenzene, this is 1,2-dichlorobenzene, correct? 1, 2, 3, 4, 1,4-dichlorobenzene, and this is 1,2-dichlorobenzene. This is the, sorry, this will change. This will be 1 bromo 4-chlorobenzene, 1 bromo 2-chlorobenzene. That will be the name of this compound, right? 1 bromo 4-chloro, 1 bromo 2-chlorobenzene. So let's see the reaction mechanism now. So this is my compound Br, let's suppose, right? So if you draw the resonating structure of this, what you'll get is bromine has lone pair of electrons, it will be Br plus, and then you can break this bond, this becomes a negative charge, and then this is what you get. And further break this bond in this direction, so it will become something like this. Further break this bond, correct. Now if you see, I'm using AlCl3 and Cl2, right? So I know what happens is, with AlCl3 and Cl4 I get H plus and AlCl4 minus. Sorry, Cl plus. See, what it does is, there is a Cl bond, slightly negative, slightly positive, right? So AlCl3 will attract this guy this side, so it will form AlCl4 minus and Cl plus, correct? So this will form the electrophile Cl plus. That is the reason why we are using AlCl3. Now the Cl plus, which we have got here now, it can attack any of the negative sides. Hope you understand. See, AlCl3, this is my AlCl, AlCl3, when it is in touch with Cl2, it will attract this Cl with a negative sign, so it will become AlCl4 minus and Cl plus. Now this Cl plus will attack the negative center, right? And this is all this position, there is hydrogen also, there's all this position, there is hydrogen also, if you see, right? There is hydrogen also here, at all this position. Everywhere there is one hydrogen. So you can draw here to be more specific, correct? So let's assume that it has attacked this position, this guy. So what it will get is, and it has, we are using the normal one because this is the resonating structure. So here it is Br, here I have Cl, and then I have H and Cl plus. Now if you see, this carbon has got a positive charge, correct? Because of the Cl, it formed a bond, Now 1, 2, 3, 4, 5 bonds to this carbon, right, which it will not like, so this hydrogen will come out. So it will become something like this, and this will be the product. In fact, it can happen at ortho position also, that ortho position will also come as a product. That is how it works. Similar thing we'll do for nitration. So if you see this one, I again take the same, let me take chlorobenzene here. This chlorobenzene, when I react for nitration, I use HNO3 with some concentration sulfuric acid. This will give you NO2. I'll show you the reaction mechanism. And with this, what will happen is, this NO2 will replace one of the hydrogen here and here. Hydrogen is everywhere actually. So we'll get the product NO2 is ortho and para, right? So this para is the major one, this is the major product, and this is a minor product. This is 1-chloro-4-nitrobenzene, correct? So let's see the reaction mechanism for this. So what is happening? I have nitric acid. Nitric acid is nothing but, this is the structure of nitric acid, HNO3. Now what happens is, when this reacts with concentrated sulfuric acid, which is H plus, what happens is, this, or you can say that H plus will attack this guy because oxygen is the lone pair here, and you will get a water, and water will come out, right? You will get something like this, positive sign and double O. This will come off, and what you get is this guy with a positive charge. That is what you'll get, and you'll call this as nitronium ion. Alright, so I got this nitronium ion. So let me start the reaction. I have this initial compound with the chlorine here, and I'm trying to create a major product, so I'll put a hydrogen here. In fact, everywhere I have hydrogen, but I don't want to show hydrogen, make this more messier, so I'll use a nitronium ion here, the positive charge. This nitronium ion will attack this carbon. Correct? Why? Because we have shown that if you write the resonating structure at ortho position and para position, it will have a negative charge on this carbon. And this carbon will get a negative charge. It will attack this position. So what it will form here is, if you see, here I have a H, here I will have NO2, and this bond will break and positive charge will come here. Right, this bond will break into minus and plus, correct? Minus and plus. So minus NO2 will be added, and minus and plus will form a bond. Hope you understand. See, if you want to simplify, what you can do is the same structure you can write like this, just for understanding. This bond you break in minus and plus, other you just keep it. Now I have NO with the positive charge. So this positive and this negative charge will combine to form a bond, correct? And these both charge will go off. Here will have positive charge. Same thing I am doing here. There was hydrogen already here. This is what I get. Correct? This is what I get. Now if you see, this is resonance stabilized actually. If you want, you can write the resonance structure of this. This is resonance stabilized. So this bond may break, and this will go in this direction, so it will form this bond here, Cl with a positive charge, H. You can further break this bond, it will form a bond. Cl with a negative charge. See, there is a resonating structure for these. Right? They'll ignore that's because it's more stable, just to show it's more stable now. And then with this, what will happen is, they want to get rid of this positive charge. So this will go off. This will go off. Sorry, this will go up in this direction. Yeah, this bond will break in this direction. So hydrogen will part with a positive charge and this will get a negative charge. And this negative charge and positive charge will form a bond. So what you get here is the same color. Correct? Because this bond broke in this fashion. This got a negative charge, this got a positive charge. Positive hydrogen came out and this negative and this positive will form a bond. This is the output you will get for this nitration reaction. Let's see the sulphonation reaction, very similar to nitration reaction. So here again I will take chlorobenzene and I am showing all the hydrogen here just to make sure that you don't forget there is a hydrogen here. Here we'll use concentrated sulfuric acid and what you get is this guy. So chlorine at ortho position, SO3H, and same SO3H at para position. This is 4-chlorobenzene sulfonic acid and this is a major product. Right. Let's see the reaction mechanism here. So in this case my H2SO4 will form H2O and SO3. Now SO3 is an electrophile. See SO3. This is how SO3 is. There is no charge on it, it's electrophile. Why? Because oxygen is electronegative. And oxygen will try to pull electron towards itself. Right? Towards itself away from sulfur. So sulfur will be devoid of electrons. Sulfur will be electron hungry. If sulfur is electron hungry, that means it is electrophilic. Correct? Why? Because if you see sulfur is not having any charge, but still all the oxygen will try to attract electron toward itself. Sulfur will become electron hungry. So let's see the reaction mechanism here. I have a chlorobenzene. I have a SO3 here to attack. So now what will happen? This is this has electron rich thing, right? It's double bond. This will attack this sulfur because sulfur is electron hungry. So what will form is this bond will break actually, and with this you get a SO3 here. Let me draw in this fashion SO3. The single draw it clearly. Correct. So I have a bond here, I have a bond here, there is chlorine here. This bond broke and I had hydrogen here. At this point I got a sulfur with a double bond here, the double bond here, and one with a single bond negative charge. How? Because when this bond broke, this also. Correct. So I got this compound and here I'll get a positive charge. Why? Because when this bond broke, right, this became negative, this became positive, and this bond, if you see this way, this became positive, this became negative, the bond broke. Here also this bond moved in this direction, this became negative, this became positive. So now this positive and negative forms a bond. So if you don't understand the flow of bond, you can just break the bond in positive and negative and try to form the bonds, right? I broke this bond in positive and negative, this is positive and this is negative. And I broke this bond also in positive and negative, and this positive and negative I formed the bond. This is the bond, new bond, right? And this positive and negative is remaining here. So this is what you will get. Now what will happen is, this is the positive charge here it want to get rid of, and there is a negative charge here it wants on hydrogen. So it will take this hydrogen from this place. Oxygen will take hydrogen from this place. This hydrogen will leave again. If you see, this bond will break into positive and negative, right? This will be positive and this will be negative. This positive and negative will form a bond. Correct? So I'm just drawing it for your convenience. This positive and negative will form a bond. So what you will get, and this hydrogen will come here. So what you get here is SOH. I could have drawn this way actually. This is OH, just not to confuse you guys. This is W. Yeah. It's all same, but just want to make sure this is orientation is maintained. Yeah. this is the chlorine here, and you get this compound. So you understood the reaction mechanism behind sulfonation. PDAZ, I have a SO3. This is electron hungry, so it's electrophilic in nature. It attacked, right? This bond broke into positive and negative. This bond broke into positive and negative. This negative and positive forms a bond. You got this. Here there's a positive charge, there's a negative charge. They want to get rid of this. This hydrogen will leave. This will become positive and negative. This positive and negative form a bond, and this positive will come here. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.